originally made this slide, I was thinking, oh, it's just a little throwaway problem, review problem. But it turns out it's a core concept that you know how some people totally don't get an idea, a concept just goes past them, but if they get this one idea, everything kind of falls into place? This number 2 is that question. If you see how I can explain this one, the rest of probability is going to make so much more sense to you. And I really want to go through it carefully. One you've seen before, though. We have 3 math books, 5 literature books. How many ways can they be arranged so the math books are together? So if you have math book, math book, math book, and they're all different, right? And then you have literature book, lit book, and lit book. And these slots are so helpful. They use boxes in the book. All right, so how many ways can you arrange the books so that the 3 math books are together? So tell me, how many ways can you rearrange the 3 math books? 3 factorial, or 6. Good. How many ways can you rearrange the 5 literature books? 5 factorial, right? And what some people do is they think of these as entities, right? They think of them as entities. And how many ways can you rearrange these 6 entities? 6 factorial. So this is just 6 factorial times 3 factorial. Another way to do it is to say it's 3 factorial times 5 factorial. And then there's 1, 2, 3, 4, 5, 6 places those 3 books could go. Well, these are the same, aren't they? 6 times 5 factorial. So that one's pretty good. But this is where it gets interesting, is with the committee of people. You got it. So Jake was saying, when we do the, how many ways this committee, can 5 randomly chosen people from 8 boys and 6 girls, all you have to do is take C of a total of 14 people, and you're choosing 5. That's how many groups there are. No restrictions. We got that. Let's use this notation, C of 14, 5, because this is equal to 14 factorial over 14 minus 5 factorial over 5 factorial. Okay, but we're going to shortcut it this way. And you can put this in your calculator, right? And get it. All right, now this is where it gets interesting. Any ideas on how you would find a committee that has at least 3 boys? Yeah.
Take 8, 2, 3, times 11, choose 2. Because 8 minus 3 is 5, plus the 6 remaining girls gives you 11 to choose from for the last 2 seasons.
Interesting. I don't know if that is the same as what I was thinking of. It'd be interesting to see.
It says at least 3 boys. It means 4 boys. It at least 3.
Yeah, so a little controversy here, but let me help with this a little bit. If we looked at 100%, 1.0, that's the sum of all the probabilities. That's the sum of having none, no boys, 1 boy. And how many total boys are there? Huh? 8. Right, your committee is going to only go up to 5. There's only a committee of 5. If you took all of these probabilities, they'd give you 1, right? So when we're talking of at least 3, we're looking at those, right? I'm not sure your idea wouldn't work.
Well, at least 3 means you got a committee of 3 boys, 4 boys, or 5 boys.
Correct. That's what I'm showing here. So what you could do, real simply, is just do these 3 possibilities. And I'm going to make this really big so you can see it. So let's do this C of 8 choose 3 and times C of 6 girls, and there's a committee of how many? 5, so this will be 2. So let's break this down. This is how many boys there are total. This is how many girls there are total. And take a moment and write this in because this is going to help you so much. It's going to help you so much. This is how many on the committee, on committee. Selected. And same thing here. This is the boys, this is the girls. Now, if we're looking at the probability, this is how many there are over the total, which you said was a total of 14, choosing 5. So this is the total people, and this is the total on committee. So look at how simple this notation is. The top is the total, the bottom is how many selected. So this is the operative words here are selected, those go on the bottom, and total, those go on the top. Is that helpful? Okay, now this is where it gets exciting. You go ahead and set up the remaining 2. See what you can get. So, Catherine, can you tell me how you set up the probability of 4? So this was for the probability of 3, success out of total. Tell me about the probability of 4. 6 choose 1, yeah, because now you're going to have 4 guys and 1 girl over. Perfect. And then the last one's just going to be C of 8 choose 5, C of 6 choose 0, over C of 14 choose 5. And it's a lot of work in your calculator, but that's what the probability is going to be. And I would be remiss if I didn't mention this. There is another way you could calculate it. Does anybody know? Or anybody thinking about it? Yeah? What did you say before?
Okay, I must have said it wrong. The way I did it, I didn't.
Oh, okay. So what you could do is, if you're looking at this equation here, that all the probabilities add up to 1. And if you wanted the purple, you could go 1 minus the probability of 0, minus the probability of 1, minus the probability of 2. And that would be the probability of at least 3. That would work too. And these actually are easier to calculate. But just wanted to make that available to you.